Okay, so let me share the screen. Is it visible to all of you?
Yes, sir.
Yes, sir.
Okay. So this was the last part, right? The last question where we stopped. And I had asked you all to just think on this part, that we were getting some absurd things by doing the derivative and all. So where does there exist a solution? Can any of you, maybe a guess would also work. Like, what do you all think? It's important for me to just know that. We did the profit maximization calculation, which was pretty smooth. The derivatives were possible and all that stuff. But after that, we were getting some very weird stuff. The first thing was we are not getting any real solution. And the second thing was that we ended up having a minimum. So what does that mean? Do we don't have a solution, or we have a solution but we can't get it in this manner? Anyone? Any guess at least? Okay. Okay, so looks like most of you are still confused. Okay, let me go back to this. To find out the profit maximizing point, you take the first order derivative, right? That's the idea. And on taking the first order derivative, you basically obtained a point which is not a real number. So irrespective of whether that's a maximum or minimum, solution does not exist. This directly gives you the answer. Does not exist. Could you all understand this? If you all can just reply with
Due to
yes or no.
network issue, I couldn't listen this.
Okay.
Can you
So
please repeat?
yeah, Ria, you have this question, the last question of the previous part,
Yes, sir.
with
Yes,
the
sir. Yes, sir. I
solution
got.
given. So
Yes,
my
sir.
point was, where we left it in the last class was we were getting some absurd things after doing the calculations and all. So we were basically trying to understand that this question has a solution or it doesn't. That was the primary question. Might be possible ki we could have solved it by some other method or something, just not that. So over here, if you just look at the solution, we take the first order derivative to find the point of profit maximization, right? And then the second order is a confirmation that indeed it's a point of maximum and not a minimum. So when you're taking the first order derivative in this question, what are you getting? You're getting a solution which is not a real number, right? That means you don't have a point of maximum or minimum. Forget about the second derivative. Okay. The very thing that the first order condition gives you a complex number makes it clear that you will not have a solution. Forget about whether that point is a maximum or minimum. Okay.
Okay, sir.
Others, can you all follow? If you all can just reply with a yes or a no. Did you understand this?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. Okay. So the last day, if you all can just maybe later on, if you just swipe through your notebooks, you'll understand that we have basically done a few kind of questions where the calculation part remains the same, but your conclusions will be differing. Okay. Another possibility, which generally doesn't turn up in any question paper, is that maybe you get a point, but you find a second derivative to be positive. That means it's a minimum. Okay. In that case, your answer will be that solution exists, but it's not a point of maximization. Okay, it's a very rare case. It doesn't come up, but just for your information, I'm just letting you know that maybe you solved it, you got a real feasible solution with of Q from the first order condition. But when you go in for the second order, you have a situation something like this. as you can see on your screen, and it's a minimum. So that means solution exists, but it is just not a solution for maximum, it's a solution for minimum. That's the simple interpretation that you will have. Okay, so if this question is clear with all of you, now let me get to the idea of integration. Some of the basic things I believe many of you might have read in your school. So let me just check on those few things first, and then I can get on to the idea. So if I just recall the definition, what is it? If d dx of a function fx is equals to f dash x, then integration of f dash x with respect to fx is fx plus c, right? That's the basic definition. Does anybody recall what this c is known as?
Arbitrary constant.
Arbitrary constant. And why do we place this?
So because the constant doesn't have derivative.
Yes, correct. Because when you take the derivative of a function having a constant value that is 0, so that will not get populated in the integral. So just to ensure that it may or may not be there, you just put an arbitrary constant c. And in general, we will call this as the constant of integration. This is something you all must you have seen it in your schools and other textbooks as well. So not diving deep into this anymore. But two things from here that I want to extend on. Look at this derivative expression once more. Can all of you confirm if you understand this? This expression can be written in this manner, right? Can you all understand? If you all
Yes,
can just
sir.
reply with a yes or a no. Correct. F dash x is known as the derivative. What is this known as? I have used this sometimes earlier as well. This is known as the differential or the total derivative. Okay. So now from this expression, you can find out the if you integrate both sides, d of fx is equals to integration of f dash x. Okay. That means if you just take a look at the left side, integration of the differential of fx. So the left side would be simply giving you fx. Correct? Because derivative and the integral are opposite of one another. So the fx are cancelling out. Okay. Is it fine? When you are
Yes.
writing integral in this format, then you will be getting this as your answer. This is often a format that you will find in many cases. So just to make sure that you understand it from later on, whether you find it in maths or economics or statistics in general, this is what it means. If you integrate the derivative of a function, you get back the function. Okay. And you can write it in this manner. That is, I think, more crucial. It is possible to write it in this way, and it is there in many of the books, at least the ones that I have come across. So now let me just recall some of the rules that we need. Can someone tell me what is this integral? X to the power n dx. Anybody recalls the formula?
It's x to the power n plus 1 by n plus 1.
Yeah, correct. Plus c. If I give you a sum of two functions fx plus gx, how would you integrate this?
So integration of fx plus integration of gx. It distributed.
Exactly. And if you have a minus, you can just put a minus as well. The next one would be something like integration of a constant times fx. How can you write this?
So
So
constant
k
part will
into
come out integration of fx.
Correct. The k stays outside. Number 4, integration of e to the power x dx.
so e to the power x plus c.
E to the power x plus c. And finally, number 4, integration of 1 by x dx.
Log x plus c.
Natural log, right? Don't forget that. Plus c. There are many others. If you just look at any math book, you will find them. These are some of them that we usually need in for economic purposes. That's why we are not going on extending this list any further. Okay. Two important things that I want to recall with all of you is, suppose we know the derivative of e to the power x. If I give you to find out the integration of e to the power, let's say mx, how would you go about this?
So it will be e to the power mx divided by m.
M. And how are you getting that, Manish? By the process of substitution, right? So let me just show you once. Maybe many of you recall that, but just for confirmation. So what do? We take this, let mx be equals to some z or t, whatever you take, and then you differentiate this. So you have m times dx is equals to dz. That means dx can be written as dz by m. So that means now your integral becomes e to the power z dz, and by using the standard formula, it will be e to the power z, sorry, 1 by m will be out. So this plus c, and z is e to the power mx, so e to the power mx plus m plus c. So this is the method of substitution. Okay. Is it fine with all of you? I would request all of you to reply with a yes or a no. It's something you might have
Yes,
done
sir.
it earlier, but you all need to be certain that you
Yes.
understand this. Others, I'll request all of you on
Yes,
this call to reply.
Yes, sir.
Yes, sir.
Okay.
Sir,
Yes.
sir, is there any shortcut to directly get the answer? Like when you just write it down the question, Manish has given directly the answers. So without solving it, how is it possible?
Uh, okay. मैं आपको छोटा सा ट्रिक बता देता हूँ.
Yeah, because if the trick is there, that will be easy for us to find out.
Okay. Let us take this function only as an example. If I'm telling you to find the derivative of this, you would find it using chain rule, isn't it? Chain rule में क्या होगा? E to the power mx in and m will come in front. Okay. And when you integrate this, उसका उल्टा होगा, e to the power x का derivative remains the same and this m will come below. That's the thing, nothing else. In
Okay.
differentiation using chain rule, it comes as a multiplicative, and in integration, it will come as divised. Derivative में आपका जो आता है, integration में उसका opposite आता है. Okay,
Okay, sir. Yes.
that's the plain and simple thing. But anyway, I always recommend that in case you're confused, please don't shy away from doing 2 extra steps of algebra. Because अगर वो नहीं होगा तो आपका पूरा आंसर ही गलत हो जाएगा. Okay. If any step if you're confused, every formula, everything will be coming out of this method of substitution. So in case you have forgotten, there is nothing to be very much worried about because you all have done this earlier, at least from the mathematical point of view. Now we are just trying to see how is to apply this in economics. So extra steps of algebra is not going to take too much of time for you all. So with this process being clear, now let me go on to the next part, which is integration by parts. Okay. That is, suppose I have two functions, let's say u and v. I want to find out the integration of u, v, dx. Does anybody recall? Maybe you all have seen this in school sometime earlier. What was this? Anyone? Okay.
Sir,
Yes, Manish?
बोलूं sir.
हाँ हाँ.
Sir, you into integration of second function minus
Okay.
integration, then differentiation of first, and then the whole integration.
Uh, Manish, repeat once more. Couldn't understand. और एक बार.
Sir, u into integration of v minus integration differentiation of u, then whole integration. नहीं sir, wrong
Differentiation
है.
of u, whole integration. Something like this. So, wait. Whole integral मतलब तो इसका बाहर कुछ something like this. Is it this Manish that you're referring to? या मैंने
No
गलत
sir.
लिख दिया?
नहीं सर, मैंने बोला भी गलत है.
Okay. Anyone else?
Sir,
Yes.
sir, u into integration of v minus integration into derivative of first and integration of second.
Okay. So derivative of first, integration of second. ये
आंसर whole integration माइनस के बाद वहां पे.
whole integration. So this entire thing.
हाँ सर, ये
ये. Okay. All right. Looks like you all have a very good memory power. You all can recall this. Wow. चलो. अब थोड़ा सा इससे आगे बढ़ना पड़ेगा इस बार. That ये आता कैसे है? We have to understand this. Because directly ऐसा और sums नहीं आएंगे कि you just apply this and find the answer. Suppose, now let me start off in this way. We have two functions. Fx and gx. What would be the derivative of fx into gx? Someone?
So f dash x gx plus fx g dash x.
ओके, मैं इसको थोड़ा एलाबोरेट करके ही लिखता हूँ फॉर द टाइमिंग. gx into ddx of fx plus fx into ddx of gx. Okay, this can now be written as the differential of this gx into d of fx plus fx into d of gx. Correct? Is this making sense to all of you? Can you understand this?
Yes, sir.
Yeah. Okay. Now, if you integrate both sides, so the left side would be integration of differential of fx into gx is equals to integration of gx into d of fx plus integration of fx into d of gx. Okay. Left side आपका क्या होगा? Integral and derivative are opposite of each other, so their effect will cancel out, and you will have fx into gx. The right side, let me just repeat this exact expression once more. Plus integral of fx into d of gx. Okay. Now note one thing. D dx of fx, we represent it as f dash x. So can I write d of fx as f dash x into dx? And similarly, d dx of g of x would be represented as g dash x. So the differential of g of x can now be written as g dash of x into dx. Is it fine, all of you? Can you understand this? Making sense?
Yes, sir.
So if I just replace this in my expression, what do I get? fx into gx will now be written as gx into f dash x dx plus integration of fx into g dash x dx. Okay, perfect. Now suppose थोड़ा सा notation बदल देते हैं क्योंकि formula में we write u and v. Suppose fx I represent it as u and कोई एक derivative ले लो आप, not the gx one. Maybe g dash x is equals to v. Suppose now I want to change the notation. Now, can you tell me, now coming to the left side, fx I will be writing as u. What do I write in the place of gx?
V.
Integration of v.
V.
Integration of v, right? Integration of v dx. Is it fine with the others as well? Can you confirm?
Yes, sir.
Yeah. Okay. Equals to, what will happen to the first expression? First is gx. This you will write integration of v dx, correct? And what is f dash x? It is d dx of u, okay? Plus fx is your u, g dash is your v. So now if you just take integration u v dx to the left, you have u integral, just a minute, u integral v minus integration of d dx of u integral v dx. And this is your integration by parts formula. Is this kind of derivation clear to all of you? Is it making sense?
Yes, sir.
Others?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So that means basically u that we have substituted over here is a function of x, and v, although it's a g dash, but it's still a function of x. So you can substitute and you can take the product integral u times v, and this is your integration by parts formula. Okay, all right. Now coming to the next part. Given any standard expression, how do you determine किसको first function लेना है, किसको second function लेना है? Do anybody recall the rule?
So islet.
Eyelet, correct. And what does it stand for? I stands for inverse trigger.
Inverse.
Inverse.
L stands for log. A stands for algebraic. T stands for trigo. And E stands for exponent. Okay. This is the rule for determining U and V. So given any integral, what you will see is that which one comes first. In this sequence, the one which will come first will be your U, and the one which comes second will be your V. Okay, any questions? Is it fine, all of you?
Yes, sir.
Okay. So now let's go on to the next part. So with these two things in mind, I'm not doing some sums right now. Now let me just discuss the application part that we have. Application of integrals to economics. Okay. Let me take example one. We have discussed something as the revenue function, right? Revenue function means what? Is the relationship between the revenue and the quantity produced, R as a function of Q. Okay. What is the definition of marginal revenue? Can anyone tell me what? How would you calculate the marginal revenue given a revenue function MR? Yes, anyone?
Differentiate the revenue.
Exactly, the derivative of revenue with respect to Q. Whenever anything in economics you see as marginal, that means you need to take the derivative. Okay. And so now the question is, given MR, we need to find the revenue function. How would you do that? So R as a function of Q would be integration of MR with respect to dq. Okay. Similarly, the next example would be example 2 is the cost function. Can anyone recall what does the cost function show us? It's the relationship between what and what?
Fixed cost and variable cost.
No, no. That's a component of cost. What is the cost function?
The input and output.
Input and output. Uh, Possibly, I'm not sure what exactly you're referring to. It's basically C as a function of Q, right? The cost incurred by a
Yes.
firm, relationship between the production level and the cost incurred. So similarly, just like the other above, over here, if I want to find out the marginal cost, MC, then how would you do that? DC by DQ. Okay. So the marginal, so now again the similar question. So given marginal cost, we want to find the cost function. So how would you do that? C as a function of Q would be integration of MC dq. Okay. Therefore, in general, for any marginal function f dash x, the total function can be obtained as fx, which is equals to integration of f dash x dx. That's it, nothing else. Okay. Now let me give you one question so that it becomes easier to understand. Suppose if the marginal cost of a firm is given by C dash of Q is equals to 2 times e to the power 0.2 times Q, and it has a fixed cost of 90 we need to find the cost function. Okay, so how would we proceed? Anyone? How do we start with the solution?
Integration of marginal cost.
Integration of the marginal cost. Correct. So the cost function C of Q would be integration of the marginal cost with respect to dq. So that is integration of 2 times e to the power 0.2 times q dq. Anyone what this integral is coming out to be?
So 10 e to the power 0.2 q plus c.
Others, can you confirm if you are getting the same answer?
Sir, at the place of C, we write 90.
Yes. How are you getting that, Anisha?
So, because C denotes the fixed cost, because the derivative of that part will be 0. So, integration of that part will be 90, the fixed cost one.
Okay, correct. uh, I'd suggest Anisha don't always take it in that way. मतलब cost था इसीलिए you could say it directly. In general, if there is something else, you need to do it in a different way. Okay, let me just show it to you. The logic that you're saying is perfectly fine. There is nothing wrong in that. Others, can you confirm if you are getting up till this part? Have you all got this answer?
Yes, sir.
Okay. So now the fixed cost is basically the cost C of Q when Q equals to 0. That is what the fixed cost indicates. So if you put Q equals to 0, then what is C of 0? It is simply C. So now that's why your constant of integration is 90. Therefore, what is your total cost? It is 10 times e to the power 0.2 times Q plus 90. This is your cost function. Okay. Let me take one more question and I'll just extend the logic. Investment which we will denote it as I of t, is defined as the rate of change of capital, which is k of t. T is time over here. Okay. We are given the investment function I of t, which is 3 times root t. And the initial capital stock is suppose k naught. The first question is find the time path of capital. And the second question is what will be the capital formation when t belongs to 1 to 4. That means basically in 3 years. Let me elaborate on this once before solving it. Investment is defined as the rate of change of capital stock. That means I of t is derivative of capital with respect to t time. Can you all understand this interpretation with respect to the statement that I've made in the question? Investment is defined as the rate of change of capital. Rate of change means over time. So investment is derivative of capital with respect to time. I request all of you to reply with a yes or a no if you understood this interpretation.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes.
Okay. So this is what they are telling us, and we are given the investment function. The first question is to find the time path of capital. Time path of capital means how capital is changing over time. That means we want to find out the k of t function. Okay. So from this expression, how are we going to find that out? K of t would be nothing but integration of the investment function with respect to time, isn't it? Understandable? And we are given the investment function to be 3 times root t dt. Okay. Can someone quickly calculate this? What is this coming out to be?
So
Sir, 2
two.
t की power 3/2.
Okay. Manish, was your answer same?
Yes, sir.
And plus c, right? Okay. So this is what it is. But in the question, there is an additional amount of information, and the initial capital stock equals to 0, k naught. What is the initial capital stock means? At period t equals to 0. Initial capital stock means at t equals to 0, k is equals to k naught. That is what it means. So if you put t equals to 0 in this expression, what would you get? K of 0 is equals to c. So that means the constant of integration is k naught. So what do you get finally? K of t is equals to 2 t to the power 3 by 2 plus k naught. This is your capital function or the time path of capital. Okay, understood?
Sir, can you repeat this one from
Yeah,
t equal to 0?
yeah. So we did the indefinite integral and got to this expression. So now the question is, can we have some information about C? If you just look at the question, the additional information has been given that the initial capital stock is K naught. Initial capital stock का मतलब होता है कि जब आपका time period 0 है, मतलब in the starting, the level of capital was K naught. Okay. So if you substitute this in this integral, if you put t equals to 0 over here, then what do you get? C equals to K naught, right? Because K naught is equals to C, and K naught, this is given to be K naught. Is it fine now? I guess it was Anisha
Yes,
asking
sir.
the question.
Yes, sir. Yes, sir.
Okay. So you got the value of this arbitrary constant C. So your total capital function becomes 2 times c to the power 3 by 2 plus K naught. In general क्या होता है आपका कि this arbitrary constant c का value you have to put something, because economically just leaving it as c doesn't make any sense. So you must be having some information in your question to put down that value. Okay. So your capital time path of the capital becomes this, or the capital function, so to say. So this is your first part. Now moving on to the second part. Can any of you tell me that what can you understand कि second part में क्या करना है? We are The question is, we need to find out the capital formation in the interval 1 to 4. That means in this range of time, what is the total capital formation?
So we have to find the definite integral
Of,
of this function, like 4 and 1.
के बीच में, right? That's
Yes.
what you mean. Okay. Others, could you follow what Harshita said?
Yes, sir.
Yes, sir.
The rest, Hina, Amrita, Tisha,
Yes, sir.
Dorothy, making sense?
Yes, sir.
Okay. So although I haven't discussed any formula yet, let me just do this sum directly. Therefore, for t belonging to 1 to 4, the total capital formation would be integral from 1 to 4 kt dt. So this is integral from 1 to 4, 2 times t to the power 3 by 2 plus k naught. So what is this coming out to be? Anyone?
Sir, I think 14.
14. Okay. Others?
So first we will integrate once again.
Sorry, what are you asking?
Nothing, sir.
Okay, so 4 by 5 remains out. So that is t to the power 5 by 2 for 1. It's 4 by 5. This is the answer. Others, can you also just check this once?
सर दोबारा इंटीग्रेट क्यों किए?
किसको?
So function 2 to t to the power 3 by 2.
कैपिटल फंक्शन तो यही है ना. This is the time part. Now the question is, in this interval 1 to 4, total capital formation निकालना है. So what is the total value of this in this region 1 to 4? To integrate. Isn't it?
Okay, sir.
Others, can any of you confirm if you are getting the same answer?
Yes, sir.
Yes, sir.
Okay, all right. Manish, have you got it? Like if you just redo the calculation, I think. आ जाएगा आपका.
Yes, sir. Yes, sir.
Alright. So that's it for today, everyone. Let me stop the screen share. In the next class, I'll be just talking about some properties of the definite integral, and then we'll continue with a few more questions. Any other questions from anyone?
सर वो डायगनलाइजेशन ऑफ मैट्रिक्स का कॉन्सेप्ट.
Okay, अर्षिता पहले क्लास में पूछ सकती थी. Okay, anything else apart from that?
सर मेरे एक दो डाउट्स और है मैथ्स में.
On what chapter?
First, quasi concave or quasi convexity, like the numerical part, how to check whether this function is quasi concave or not.
Okay, I'm yet to do that, Harshita. I haven't done that in general abhi tak. It's there in the next week probably I can get to that. Okay,
Okay.
anything else? Anybody?
So, my message to Saurav sir regarding